Greetings, everybody. My name is Sidney Suen. I will be presenting my recent submission to Sentic ICDM. So it is a multi-layered prompting of small language models for Twitter sentiment analysis. So the motivation is that the main aim of the work is to tackle the more nuanced and complicated facets of sentiment analysis. So traditional approaches tend to struggle with the more complex tasks, such as sarcasm and irony detection. So sentiment in social media context can be shaped by linguistic nuance, cultural references, and implicit affective cues. They require external knowledge and pragmatic inference mechanisms. Hence, we do need explainable models. So take this tweet, for example. We have a tweet in Italian, but if you peel apart the layers, we can see that there are many aspects that you have to unwrap in order to truly understand like the deeper sentiment in terms of like linguistics, in terms of pragmatics, as well as the cultural aspects as well. So the research question of this study is we want to investigate how well small language models can handle the cultural complexities of social media content. And we also want to see if prompting strategy can be used to guide the model to think along the correct dimensions, so to speak. So this work was inspired by the many prompting strategies such as chain of thought or tree of thought. The main gist is that they are trying to guide the model down the correct path of reasoning. Of course, these are originally designed to be agnostic tasks. So any kind of general purpose reasoning task will be addressed by these prompting strategies. So our work tries to build upon this by introducing a multi-layered prompting strategy for sentiment analysis, and they are catered to 4 very specific layers: lexical, contextual, pragmatic, and cultural. So this is the data set we are trying to work on. It is an Italian Twitter data set. There are 3 separate subtasks: subjectivity detection, sentiment polarity, as well as irony detection. So you can sort of infer that like with this very elaborate labeling scheme, we can see how we can obtain very nuanced classification of different types of social media tweets. Hence, this is one of the perfect data set for this paper research. So we used 3 different language model families. We use DeepSeek, we use LLaMA, and we use Qwen 3. So these are the smaller ends of the models. We try to use 8 billion parameters and below to see how well the language models will perform on the edge computing device. So in terms of hardware configurations, we use an NVIDIA 3080 with 10 gigabytes of VRAM. So the Qwen models 4B tends to take about 13 hours. Qwen 8B takes about 6 hours. DeepSeek 7B takes about 3 hours. And the other models tend to take about 1 hour for a full iteration. So one of the main reasons why these take a lot longer is because there's a lot of effort and resources spent generating the reasoning tokens. But we do note that these help the models reason over the very complex sentiment analysis task. So this is the prompting strategy. Metaphorically speaking, a sentiment can look like an iceberg. So we peel apart the layers and we go deeper and deeper. And we guide the models by prompting it to examine specific aspects of the tweet, which would affect its final judgment of the sentiment. So this is the prompt template that the language model will receive. So we break it down into various sections, such as the prompt prefix. This is the section for the multi-layered reasoning. There's also the labeling schema as well. So we try to guide the model to label the data set. based on the guidelines of Sentic policy. These are some examples that will be included if there's a few short scenario specified, as well as the input tweet and the output specification, because we want output that is parsable by machine reading tools. So JSON is one of the best for like object-oriented parsing. So in terms of the qualitative rubric, we use Claude 4 and GPT 4.1 as the language model judges. We define an itemized rubric with defined criterion. Every language model judge is presented with these following data. And as you can see, it's a very sophisticated rubric that specifically defines a scoring system. So this allows people to basically identify specific layers in which the model performs good or bad. So in terms of the prompt formats, we have 4 different aspects. We have the vanilla prompt, so just a labeling schema, no multi-layered reasoning. We provide the model with labeling and multi-layer reasoning for the multi-layer prompt. We add, for zero shot, there are no examples provided, but for few shot, there are 5 examples provided. And these are the quantitative scores. So what we notice is that, okay, so exact match is the number of, the proportion of the data that actually matches the label, like every single one of the 6 labels that were previously defined. And we also have a valid percent, so you needed to track how many structurally correct outputs were generated by the language model. So these are the F scores, which are like an amortized calculation of all the various F scores of the different categories. So if you want to find more details, you can consult the Sentiposi instructions. It's a bit involved, so I will not go into too much detail. But so if we take a look at this data as a whole, we notice a few trends. So generally larger models tend to do better. There are often trade-offs noticed in the performance for most SLMs. So a model that does better in one category might suffer in another subtask. Of course, we also note that like the traditional baselines will beat most LLMs across like different parameters. Of course, there are a few exceptions. In terms of the prompt formatting, few shot prompting tends to help in most cases. As we can see, some models, the exact match scores actually improve over course of like for Qwen. And multi-layer prompting also benefits models in some occasions, but it is noted that the Qwen models benefit the most from them. So in terms of model-specific trends, we do note that the very small models like DeepSeek R1 1.5b, the performance actually worsens across prompt formats. LLaMA 3AB struggles at irony detection. It actually plummets to 0 when we introduce the multi-layer prompting format. And another exception to this trend is that we do notice that Qwen 3 models do the best among their contemporaries. Irony detection actually exceeds baselines for Alberto and the Sentiposi teams. Of course, we do know that the baselines were originally machine learning based tasks. So while they excel in like surface level pattern matching, they may not do well on like irony detection, which might require like external knowledge or more sophisticated training patterns for like the Qwen 3 language models. So this is the scores of the judge. We do know that the inter-annotator agreement is quite poor. It ranges from 0.2 to 0.6. So this underscores the subjective nature of the qualitative evaluation. We do note that the quality of the explanation based on the scores are correlated to the quantitative performance. And we note that the Qwen models tend to proportionally receive the highest scores from the judges. Of course, the DeepSeek R1 1.5b receives the worst, but a large portion of the reason is due to the fact that it is unable to generate the correct format of output. So it is thus penalized by the judges accordingly. So it's not enough to look at the quantitative side. I'm always interested in evaluating the qualitative nature of explanations, because if you look at DeepSeek 1.5b, we notice that the explanation quality is very bad. And not just that, it is also known to either misread the situation or even hallucinate context and meaning entirely. So this is kind of a proof that even if it does get the right label, its explanation is really poor. So how trustworthy is it? And we can look at it from the flip side. Qwen 3.8b actually does quite well. The quality of the explanations are really good. They have specific reference to the context as well as cultural background of the tweet. So we can sort of see like the explanation of the language model can correlate somewhat to the quality and the trustworthiness of the language model's explanation. So in conclusion, I want to iterate that the model type and the training does matter. We do acknowledge that DeepSeek was originally optimized for coding and math, not really linguistics or culture. LLaMA tends to be more conversationally trained, so maybe they not have the instruction tuning to generate robust JSON output. Of course, Qwen does the best, so a large reason for this could be due to the fact that it is reasoning capabilities as well as tuned for instruction following. So that's one explanation. So in terms of addressing the challenges of sentiment analysis, one of the main conclusions I want to make is that irony can have a cultural component to it. Small language models will most likely struggle compared to the large language models, which tend to have sufficient representational space. So a lot of the world knowledge is better represented in the larger parameter space. So in terms of our experiments, we do note that 8 billion parameters seems to be the sweet spot. Any smaller and the model will struggle on complex reasoning tasks and generating outputs in JSON. So for future work, I have thought about 4 different directions. We do need smarter sentiment. We don't want to just calculate the polarity. We need to decode the intent, the tone, as well as the emotional strategy. And we also want layered insight. We think of that granular ablation can reveal which linguistic or cultural layers will drive the performance of the language model. Context-aware parsing is also important. We need to capture idioms, irony, and schema cues across diverse registers, because sometimes you may be English, but it may not actually be a native speaker, so they might convey ideas somewhat differently, or they might use expressions from their own culture translated to English. So that's another important consideration to have. And lastly, we also need to think about the cultural zeitgeist as well, because a lot of the political tweets and the data sets tend to function like a time capsule where they would have a snapshot in time where the political, cultural, and social mores of the time actually does play a very huge part in shaping not just people's sentiment, but how they perceive and they understand the world as it is. Of course, these are very important, how to say, dimensions that we need to consider, because we've moved beyond the phase of pattern matching. And so if we want to truly put the analysis in sentiment analysis, this will probably be the next frontier to explore. And with that, I will conclude my presentation. I thank you for your time.